Alright guys, so I want to talk about two theories that we use in oceanography, and both of these theories are very important, but the one is more so than the other, and it's the accepted theories to what we actually use in geology and the building and all theories that come from what we understand in geology. Alright, we have catastrophism versus uniformitarianism. These two theories are how the world was formed. They basically tell us how we got here, how the earth began. Where the world became goes back to almost 23,000 years. We've asked that question for many, many years. But this is when the Greeks found their very first fossils. The very first fossils were discovered, and Aristotle made the attempt to actually answer what these things were. And what he said is they were fish that they didn't move enough, so they ended up being found in these excavations, and they were fossilized. So I don't think he really had a good answer for what that was, but that's what his theory was at the time. Catastrophism developed in the mid 1600s by a gentleman by the name of James Ussher, who was an evangelical bishop, actually. He was a respected Bible scholar, and what he did is he went back and he developed his theory and went back in time and counted the thousands of years in the Bible, and he came up to the idea that it was quite possible that the Earth was only about 4,400 years. And he did that by counting the generations in the Bible and developing this. Now, this theory was really accepted early on there, and it was accepted because it was really the first big attempt at this. So he was able to use that as a very much claim to fame for him, and Europe really began to develop this, and science believed it at the time. Catastrophism during the 17th and 18th centuries. Catastrophism was a big influence on the way people thought about things and how they believed stuff. They believed that catastrophism was that Earth's landscape was shaped primarily in great catastrophes. So you had huge floods. Of course, that's in the Bible, large volcanic equations, earthquakes, these kind of things. This is how they thought, and it happened very violently and rather quickly, so this is how the Earth was formed. Uniformitarianism, on the other hand, was developed by a Scottish physicist by the name of James Hutton. He wrote a book called The Theory of Earth, and he published it in 1795. This theory is really a pillar of what geology is based on. Everything we do in geology and we'll do in this course is based on uniformitarianism. This is our main theory. It states that physical and chemical and all biological laws operate today, what we understand as today, all these theories and laws that happen today, operated in the geological past, so this is really nothing new. So in other words, these forces and processes that happened in the past continue to happen today, and this was the development and the gradual development of the Earth. We have this supported through ancient rocks. We can carbon date them, see how old they are. They tell us a lot. And a first understanding of the present day processes. So we had a lot of scientific method here. Prior to Hutton's theory, there's no real evidence was proven up to this point as to how old the Earth might really be. Some of the additional evidence we come up with is the formation of the mountains. Mountains are sculpted by of course, the continents coming up. You get the push up of the rocks, and over millions of years, we end up with a deterioration of that rock. It's estimated that the Earth is about 3.5 billion years old from all this evidence. It's not a single step process that develops that and tells us this. What it is we're able to see just one thing. We take all this stuff together, put it together, and it leads us to that. Some of our oldest fossils are 2.5 million years old, and both, of course, are aged with radiometric dating. So this is very hard science that we understand. You can see this is some evidence right here of what ripples look like on the beach. If I was to compare that to some fossils, you can see that this is a fossil of that same kind of ripple. So we're able to go back and forth, see what we have, and this is what happens modern today. We go back in time to about 2.5 million years ago, and we end up with these same fossils. Another example of this is modern mud. You've probably seen this around here when we get a big rain and things start to dry out, you get this cracked mud. Well, that happens now. But if we go back and look at fossils, several million years old, there it is again, same kind of thing. So this is the kind of stuff that we expect to see. All right, you should be able to take notes on this stuff. You can pause, go back, whatever you need to do. Add your notes. If you need some additional information, check out your book. It also talks about these two theories. You have an assignment that goes with this. So it's a two-part series. You've got the notes you'll do, and then you're going to do the compare and contrast between these two. All right, good luck.